Hello. I'm going to do a video log on unit testing. I am not a big unit tester, and I'm going to get into it. I know it's a great enhancer of software development, and I've done some in the past, and I had a small kind of mini project I did recently where I decided to um, get better at unit testing, and I decided to do my unit testing on this mini project, which was building a Connect 4 game. Um, so diving right into it, the big thing with unit testing to get started is the different phases of testing. Um, which is you know what, maybe I don't want to get into the phases yet. Um, in summary, the power of unit testing is that it allows for development to occur quickly for complex and larger code bases. So the larger your code base is, when you want to do a new feature, there needs to be a checking of all other existing features to make sure that nothing broke, right? Well, if you have unit testing done on all those existing features, and you go into the code and you make changes, maybe you're changing something that affects other features and doing the new one, well then, if you're using unit testing, you can very quickly, because the tests are automated, do the unit tests and know that you're in the clear because the unit tests pass. So that's the power of unit tests. Um, the I'll get into the phases of unit testing in a little bit, but I think I'll go for an example that would explain unit testing to a layman first. So this example I'm going to use, it comes right out of a research article that I found. It was a Martin Fowler article on unit testing, and it deals with two software entities. One is the system under test, or SUT. This is a term I read about right out of the article, and that is an order. And the collaborating object, excuse me, is a warehouse. So what happens here is there first is the actual behavior in the application, which is an order, and let's say an orders execute. My dogs are coming in here. An orders execute function is called first, and then there's a checking of warehouse quantity for the orders product, and if there's enough quantity, then order is processed, and as a sub part of that, the quantity in the warehouse is decremented, and if not enough quantity, order is not processed. Processed, let's say processed might be shipped or something like that. Okay, so this is the actual software feature, right? Now, what we want to do is be able to unit test the order entity, the system under test. So here we'll do unit test upon order entity. So what happens is what we can do, we gotta think through, if you're somebody that doesn't know this stuff, and that's the approach I'm taking, how do we know that the software features behavior and state is as expected? So how do we know that stuff like the quantity being decremented occurs if there is enough quantity? And how do we know if there is not enough quantity that the order is not processed? Well, we do unit testing, and what we follow is 4 main phases that allow for us to ascertain if the feature and its behavior and state during this whole process of what happens is as expected. So essentially there's setup. So for this case, it would be things like creating order and warehouse objects, let's say. Setup isn't too complicated here. And then we have the execution phase. Here we can say actually perform the software code / actually call, let's say this, actually execute the concerned entity being tested, which in our case is the order entity. And it will call the execute order, and there's 2 different tests we'll do. One where the warehouse object is set up with enough quantity, and one where there is not. And then 3, what's called the assertion phase. So based on based on setup of objects, assert that state of objects after execution is as expected. So for I gotta have one other section here. So let's say test 1. So test 1. Success, or I don't know if we want to call it success, but order gets processed scenario, let's say. We will do our setup. And this mainly, what we're mainly concerned with here is making sure that warehouse has quantity, I don't know, quantity 100 of toy 1, right? Then we'll do execution, and we're going to call order execute, and we'll pass in our warehouse here, right? And well, actually, I'm going to do this a little bit. I'm going to construct the order with certain parameters that specify what the product is and what the order quantity is. Order is constructed with, it's constructed for toy 1 with quantity of 50, right? So when we call order execute and pass in warehouse, order can, in the implementation of execute, it can it will query warehouse for the amount of toy 1 in the warehouse. Well, that amount is 100, and it only needs 50, so that means it can ship, right? So that leads us to our assertion phase. And what we do here is just assert that warehouse's quantity is now 50 because order was processed / shipped, right? And then okay, so this is the main rub right here. We set up our software entities, the system under test, and the collaborating object, and we executed the function that is being tested, and we know that this function works as expected by our assertion, which is that, of course, the quantity changes because order changes it, since there was enough quantity in the warehouse for the specified toy. That's it. And then the last phase, as you can see, actually I haven't mentioned it, is cleanup. So, shoot, I gotta kind of copy and paste. It's kind of hard to scroll down. Or I can't move the recording window. Okay, so the fourth phase is cleanup. And cleanup, it's an important step because it reinitializes objects that are used in other tests, so that one test does not muddy the environment and throw off expected results for another test. So let's say re-initialize test environment objects. So that they don't throw off further tests. And you know, I won't even put that in here. The next test to look at is going to be, I'll just mention it, is test 2. Order does not get processed scenario. So we're changing the setup a little bit in this scenario. I won't even write it out, but essentially you give a setup where quantity is less than what the order is asking for, and what we call order execute, and we would expect or assert that warehouse quantity does not change because the order would not be processed. That was what we would do for test 2. That's it. I'm going to talk about some more stuff and give myself a new file to write in. 1 second. Okay. Up next, in talking about testing, is the different type of what are called test doubles. Comes from stunt doubles. So a recurring theme with doing unit testing, automated testing, is the need for these fake objects, and there's a variety of these fake objects. Some are simple and not powerful, but not heavy or hard to produce. Others are take a bit of time to produce and are heavier, but of course are more powerful. So we'll start from the easiest ones to produce to the heavier ones. Cool. So number 1 is this is me just going from what I researched online, and I think in the comments section I'll post those research links, but this is just straight out of what I'm researching, and it's just a log. I'm not like an authority on this stuff. Okay, so the first one is, if I can remember right, is dummy. So dummies are I'm kind of getting a little bit out of explaining like to a layman here, and me just kind of practicing and explaining it to someone that would code from here on out. But a dummy is just an object that's like a filler. So if we're testing a if we're testing a SUT, or system under test, speed up testing by filling in argument lists or expected data with dummies. So these collaborating objects that may be argument lists to functions being called or constructors being called, um, they can just be filled with objects that are empty or null objects and do the job of of allowing for these objects that actually are used in production to not have to be produced in the test, since that 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 process might take more time, and the actual execution of the code, like producing those objects, may take time, and it may take more time for the user to import those files into their code and stuff like that. So they would create dummies. Number 2 is spies. So a spy is it's the ability for a unit tester to replace a function that is called by a system under test with what's called a spy. And there's a recording of what's done to the spy. And then after the test is done in the assertion phase, one can assert that certain things happened to the spy. Like the spy was called or the spy was not called. And of course, based upon the setup, you're going to want to see assert that either of those spy called or spy not called states occurred. And for brevity, I'm not going to write out everything. The next one is stubs. Stub. Okay. So to remember what stubs are, here, let me gather myself here. I know what it is. It's just not coming out right now. A stub is it's a fake object that acts like a collaborating object for a system under test, and it gives prearranged responses. So it might be the server collaborating object that responds, or it might just be a general collaborating object in whatever programming language you're using that is called by the system under test, and returns some prearranged data. And that prearranged data actually brings about a specified code path and brings about a certain state for the system under test, which can be asserted. So you're seeing how stubs can be useful and unit testing. Why? Because your one is creating these fake objects, again because it's easier to create these fake objects than to actually just do the real thing, because then you're not really automated testing, you're manual testing. The next one is mocks, and I was reading about mocks, and there's a bit of confusion in the community about mocks and stubs and what's the difference, and there is a difference. What it is what was it? Once again, my my mind is not having it come forth right now. So, what was the part of mocks? Okay, I'm just going to go to my notes. Okay, the best way I can explain mocks, it's my way of explaining it, is it's like a spy and a stub put together. So, stub is a fake collaborating object that will give prearranged responses to the system under test. It will do that. Mocks will do that like stubs do. Mocks will also do what spies do, which is record behavior upon it, or record what's done upon itself. And the big thing that I was researching is that mocks are what is used in behavior-driven unit testing. So what I was explaining before in my plain simple example with the order in the warehouse was state-driven. So it was doing this setup and execution and assertion, and the assertion was doing assertions upon the state. So that's state-driven unit testing. With mocks, I'll have to verbally explain this for brevity once again. With mocks, there can be assertions that assert upon the behavior of the system under test. So I am going to kind of just write out what I made notes on here. So the example I have is this. So we have a warehouse mock, and it will expect that it is called and the method called is has inventory, and it's called with the method has inventory is called with toy1 and 50, which is the quantity, and returns true. So this is the setup for the behavior-driven testing using this mock, and you can see here how it's acting as a stub. It's saying what it returns, and which is kind of like a stub. It's also acting like a spy and recording the behavior upon it, like it is expecting to be called, and what the method is that is called. So that what I was reading, there was a bit more to the example where the warehouse mock could say the next bit of code would say expect called method deduct inventory, right? So and called after like above call. This is pseudocode. So the important thing here to realize is there's a testing of the behavior of the system under test. / order. That's it. So the behavior is that there is this calling of inventory first, and then there's this calling of deduct inventory. And this is expected behavior for the order because the warehouse has enough quantity, and after it's checked, has inventory, what is expected is there is a call to deduct inventory. So you can see this kind of second way of doing unit testing, which is the behavior-driven unit testing, and that's that. Okay, the last part I'm going to get into is showing my Connect 4 unit testing code. So I did this using Angular, and what I am using for the unit testing framework is Jasmine, and the part that works with Jasmine that actually sets up the browser and does the execute what Jasmine specifies as the test is Karma, and you don't actually see those as being imported because they're implicit imports in the test when they're executed. You are seeing some imports here like Angular Synon, which is or Synon, which is what's used for making spies in my example. And this part here is a little bit it's a little bit hard to start with, so I'll get to explaining this soon. Just 1 second. Oh. Okay. So what's pretty cool with this is that I'm finding a way, or I found a way, the way to do unit testing with Angular using Karma and Jasmine, and using Angular that is Webpack'd. It takes a bit of doing, and for those that are interested, I have my setup in Karma in a README file, which I can link to. And there's a lot of stuff to install, and some kind of guides to definitely follow to make it all work. I don't want to get into that too much, but I just wanted to mention it. Okay, so the way this works is we have a description of the methods being tested. Like this is the init method of the Connect 4 entity that's being tested, and I'm having 2 tests happen on it. So it's a Connect 4 game. And, you know, the core of Connect 4 is what I really want to show first and how that's being tested. And that is check for win, right? So, you know, the check for win function is a function on the Connect 4 entity. And it should definitely return true if the board that had a move or moves done on it has a win condition in it. And the way that I'm doing this is by having the board filled with in a row, this two-dimensional board, having the first 4 rows or columns, depending upon how you orient yourself, having the first item in those rows or columns be filled with 1, and 1 is an indication that the coordinate on the 2D board is owned by player 1. And then we call for check for win, and here's our assertion being happening here. We expect that check for win is true because we set up our entity to have a win condition. Then here's what's expected when the board does not have a win condition. The check for win will return false, right? And I don't need to do any setup because the setup that happens on every test is enough, as no players, player 1 or player 2, owns none of the board. One thing to mention that I kind of skipped over was there's these before eaches, and it may look a little Greek to you, but I'll try to walk us through it here. So don't look at this stuff, but right in here is where Connect 4 is before each test, because we want to have tests be isolated. We're hooking into a new Connect 4 entity, and because we're using Angular, this inject function here is an Angular function. We need to have Angular basically produce it for us, and we have our Connect 4 variable, which is outside the lexical environment of this function, hook into what Angular produces before each test. So we basically have this reference to the Connect 4 entity, and we initialize it. And that is how we are able to reference what is tested. So we're able to have access to what is tested and set up, which is the Connect 4 and its board and its methods. So that is that. So there's one more part to get into, because I was explaining some of those test doubles or fake objects used in unit testing. So in my code here, I am using a spy. So look at this code here, and see, I'm using a spy. So, gosh, it's kind of hard to, it's a bit hard to explain because it's gonna seem kind of like Greek, but I'll do my best to explain it. Angular allows for a developer to say what the game collaborating object is by using this provide value method. And what I'm saying is that the game service is this object that has an insert game method, which I am assigning to a send-on spy. Pretty cool. And then what I'm expecting here is that this game insert is a send-on spy because I set it up as that before each test. I'm expecting that it is called. And you're not really seeing the what's kind of cool is, and I'll show the code for it, is connect for init does happen before each call, but it actually doesn't call insert game. There's like base code that's run on the very first initialization of connect for that calls insert game. Maybe I shouldn't have mentioned that because the example would have worked fine it would have worked fine for a user being presented the content and just gone along with connect for init being called and being what calls insert game. But I just wanted to say that. So essentially, Angular, in producing the connect for object, does that very first initialization, just to explain completely what I was getting into. And that code looks like this. So here's all the code, and you can see here we have, this is the actual entity connect for. We have our init function, we have like the move function further down, we have the check for when. And here in the like very first initialization, not init, which is used for resetting the board and doing other initialization matters. Here in the very first initialization of the connect for entity, we have game insert game, this, which is the connect for entity. So this is important, and I don't want to explain why it's important because of brevity and finishing up my presentation here tonight. But the important part in our context is that we can pose the game entity not as what it actually is, but as this object with a spy, and make assertions off of it, and further ensure that the code is acting as expected, which is very good because we're unit testing, and this is very powerful. And as I explained at the very beginning, it's very powerful because as we're developing new features, we have all these automated tests and unit tests that are there and can detect screw-ups that occurred because of developing the new feature very, very quickly, as opposed to the alternative, which is having to manually test everything, which gets tougher and tougher the larger the code base gets. So that is it.